Hello guys, today we're going to finish 2.6 composite functions. Here we have a formal definition for the composite functions. So you can pause this video to look at this definition. So the main part we want to know is anytime we have something like this that is read as f of g of x, this is equivalent to f of g of x. And then here we have a graph. If this graph makes sense to you, that will be awesome. So we have an input x, all right, and go into the function g, and then your output is g of x. And then here we're going to have an input g of x, and then you go into function f, and that is your output is f of g of x. All right, here we have the domain of the composite function. So we say right here, if you look, x is the domain of g, okay? So that is the same thing as right here we're mentioning, all right? So x is your domain of your g, okay? The second sentence, g of x is the domain of f. So if you look right here, so let's use the matching color right there. So this g of x is your domain for your f. So that is where the graph comes from. If you don't understand this graph, it's okay. Let's do some example. Hopefully that make more sense to you. So we have example 5. We continued from 2.6. Given f of x equal to 3x minus 4 and g of x equal to x squared minus 2x plus 6. So we're going to find each of the following. So first let's take a look. Part A is f of g of x, so that is equivalent to f of g of x. So what happens here is we're going to look at g of x. So all you're actually doing is we're just do a substitution. That is x squared minus 2x plus 6 is g of x. All you have to do is substitution. So we're going to rewrite this as f of x squared minus 2x plus 6. So once we have this, we have been doing this for a long time. Anytime you have this parenthesis, in the past we mentioned, all right? So anytime you have something like this, all you have to do is any x you see, you replace this with inside your parenthesis. Did you remember I mentioned in the past? Even it's a dollar sign, triangles, we just going to replace whatever's inside your parenthesis for your x, all right, right there. So let's do a substitution now. That will be 3 times, okay? So I'm just going to write down the parenthesis because we see an x. So I'm going to write it down. That will be x squared minus 2x plus 6. And then the whole thing minus 4. Once we have this, we're just going to simplify. We're going to have distribution. So that will be 3x squared minus 6x plus 18 and minus 4. And then the last step, we're just going to collect like terms. That will be 3x squared minus 6x. We have 18 minus 4. That is a plus 14. That is your final answer. Okay. Part B, we have a g of f of x. So we're going to rewrite this as g of f of x. Once we have this, so we're going to look what is my f of x. So right here is my f of x. So now all we have to do is substitution. I'm going to write g of 3x minus 4. So we're going to find the g of 3x minus 4. So given to us g of x equal to, we'll go back and look here, okay? So given to us g of x equal to x squared minus 2x plus 6. So that means every x I see right here, we have to replace this with 3x minus 4. All right, every x I see, I'm going to replace with inside this parenthesis. So that tells us that will be 3x minus 4, and then outside is a square. And then minus 2 times, again, we see an x, I'm going to replace with 3x minus 4. Okay, then plus 6. So again, where that come from? So we go all the way here, all right? So once we have this, and then the rest of the stuff, we're just simplifying. 3x minus 4 squared, is, you can just use the formula a minus b squared equal to a squared minus 2ab plus b squared. We can use this for 3x minus 4 squared, or you can use the FOIL method, whatever you feel comfortable with. So this whole thing gave us 3x squared minus 24x plus 16, and then now we'll do a distribution. That will be minus 6x plus 8 and then plus 6. So rest of the step we just have to simplify this. So we collect the like terms. That will be 9x squared. We have x here. That will be negative 24 minus 6. That will be minus 30x. Then we have 16 plus 8. That will be 24. 24 plus 6 is 30. So our final answer is 9x squared minus 30x plus 30. Alright, so that we finish part B. So let's look at part C. G of f of 1. Because from the part B, if you realize from part B, we already found this solution right here. Alright, so we found the g of f of x equals 9x squared minus 30x plus 30. So if we're looking for g of f of 1, all you have to do is we're going to plug 1 for x. So that is equivalent to 9 times 1 squared minus 30 times 1 plus 30, which is going to be 9. Alright, I wrote it. The reason, because from part B we found g of f of x equals 9x squared minus 30x plus 30. Basically did is we substitute for your x. That's how we found 9. So there's another way to do it. So we're going to show you guys really quick if you want to use another way. So another way to do it is g of f of 1. So we can actually look at this as g of f of 1. Okay? Because you could find the f of 1, right? You can find the f of 1 by plug this 1 for your f function. If you look at your f function, just 3x minus 4, that will be 3 times 1 minus 4. This whole thing is going to be negative 1, right? Because your function f of x is 3x minus 4. This is given to you. So then from here, then you plug your negative 1 in your g function. Alright, so given to you. So your g function is, go back and look, g of x equal to x squared minus 2x plus 6. So if you're looking for g of negative 1, you're just going to plug in your negative 1 for your x. So in this case, that will be 1 plus 2, 3 plus 6, that will be 9. So you're going to have this equal to 9. Look again, they are exactly the same answer, okay? So whatever the method you want to use, that is fine with me. Alright, this is method 1, this is method 2. So now let's look at part D. Part D we have here, part D we have f of g of 2. So what I'm going to do is, I'm just going to use the function we found from part A. So I'm just going to plug in, that will be 3 times for your x. We're just going to plug in for 2. So let's see if I can put another color. So there's a 2, we're going to plug in for your x. Okay, so we're going to plug in. So you're going to have 3 times 2 squared minus 6 times 2 and then plus 14. Okay, all we're doing is substitution. Then we're going to simplify this. This whole thing equal to 14. And then here we have method 2. I just found the g of 2 first, okay, which is 6 right here. Okay, so I found my 6 right here, and then I plug in here, replace it, that will be a substitution. So once I did this, I found my f of 6 by plug this 6 for my x. Okay, so if you look right here, I get exactly the same answer. Both solutions get the answer is 14. If on your test you have extra time, I highly recommend you guys to check your answer by using different method. Alright, let's go ahead and work on example 6. Example 6, we have given f of x equal to 2 over x minus 1 and g of x equal to 3 over x. So we need to find each of the following f of g of x. So let's go ahead and take a look. For part A, f of g of x. Okay, step 1 I always like to do is rewrite this as f of g of x. Once we have this, we know this is my domain for f. Alright, so all I have to do is I'm just do a substitution right there. So now I can rewrite this as f of 3 over x. So like what I mentioned in early cases, once we're looking for f of 3 over x, every x I see here, okay, look at your f function right here. So every x I see, I'm going to replace x with inside this parenthesis. Okay, so what I'm going to do now, I'm going to write it equal to the original f of x equal to 2 over x minus 1. So I see an x right here. Let's use this color. I see an x right here. I'm going to replace with inside the parenthesis is 3 over x and then minus 1. So once we have this, we have simplified it. I'm just going to get rid of parentheses. So all we have to do is we're going to multiply x over x. The reason why, because I see this. Okay, the reason why, because I see this x, I want to get rid of it. So then next step, I just have to do a distribution. Alright, in this case, we don't have the distribution for the numerator, but I have to do that for the denominator. Okay, that'll be 2x over, okay, so think again, that will be distribution 3 over x multiply x, and then minus 1 times x. Alright, that's my distribution. So I'm doing step by step. Okay, so if you understand this, you can perhaps fast forward video. So then there's a whole thing that will be 2x over, so x cancel, that will be 3 minus x. Okay, so that is your final answer for your part A. Okay, again, go back and look. First, write the f of g of x, and then any x you see for f of x, and then you replace with 3 over x. And then you simplify it, and then you get final answer. So for part B, we have to look at the domain f of g. Okay, so for domain, we'll have to look at a couple of things. So first, from here, we look. Alright, let me use a green color, blue color. Okay, from this 3 over x right here, we realize x cannot be 0, right? We have to go back and look here, alright? And then x cannot be 0 because this is 3 over x is a denominator. Another piece right here, we're dealing with denominator again. That means 3 minus x cannot be 0 as well, so x cannot be 3. From this two-piece information, we know x cannot be 0 over x cannot be 3. So which means we have to exclude those points. So I'm going to write this on your number line. It's the easiest way for us. If you're used to it, you don't have to do this anymore. Okay, so we have to exclude 0, we have to exclude 3. That means we have to draw an open circle. So everything else, it works. So now I can write my domain from the left to the right. That will be domains from negative infinity to 0. Exclude 0, that's why we use the parenthesis. And then anytime we have something like this, we're going to use a symbol or, and then from 0 to 3, again we have another or from 3 to positive infinity. That is how we write the domain. Again, thinking about this is called 3 intervals. That's why you have 3 pieces right here. Okay, that is how we do this example 6. So please make sure to do some homework and ask questions. Keep working hard. Thank you for watching the video. I'll see you guys next time.